I'm streaming now. Wait. Oh yeah. I think for today I don't have long material, so I hope we can end our conversation around 5, perhaps. But let's see. Oke, kemarin kita sudah sampai di sini ya kalau nggak salah. Jadi ada ilustrasi untuk yang bidirectional search dan juga ilustrasi untuk apa namanya algoritma yang lain. As well as with bidirectional search, we search for uh, initial state as well as the goal state. Okay, and what we returned from the our searching algorithm, which is the path of our tree, or the what is it, the operator sequence of our tree, and it's coming from this state, operate to that state, and then operate to that state, and then operate to that state, operate to that state, going to that state, and then finally we will reach the goal state in there. And uh, for the next algorithm, we will see different approach, which is we will call it as what is it, informative search, or yeah, informative search, since we use the heuristic in our algorithm. So previously we didn't use any heuristic at all. We just what is it, expand the whole applicable operator. For example, like from the first state we go to we will generate the child of the first state to each of operator, or the operator that is applicable to the first state. And for example, in these pictures we have 3 different states, and the one that we followed in our algorithm, we never see any information at all. We just follow kind of mechanism, and follow that algorithm, and it's what is it, it has a pattern. Oh, sorry, I haven't shared my screen. Yes, thank you, Mas Andi. I haven't shared my screen. Okay, have you seen my screen now? Sorry for it. My mistake. Okay,
Good,
thank
good.
you. Okay, so in the previous explanations, we have a couple of algorithm, and all those algorithm never know where the goal state is. Okay, we don't have any clue where the goal state is. Imagine that coming from the first state, we will generate the whole child for the first state, and then we will follow the algorithm. For example, like when we apply the uh, breadth for search, we will search and check the state level by level. And if we use the depth for search, we will go to the highest level first, until the level is exit, and so on. And when we use the uniform core search, we sort the the next iterated state based on the cost. Okay, and meanwhile, in the next class of our searching algorithm, we will use some informations. Okay, so in the previous searching mechanism, we don't know, well, we didn't know that the goal state is strictly directly to uh, these directions. Okay, for example, like when we that's why when we go to the breadth first search, We will search the area and not directly go to the goal, but circling along around in the area which is near to the initial state. And when we continue to the depth first search, we will circle around to something which is depth, and we didn't, to be honest, we didn't actually know whether our direction is correct one or not correct one. Meanwhile, in the next class, we will use some informations. For example, like when we are in this state, we know that we will maintain an information which is we will go to next state, okay, which is the goal is not going to the other directions, but we will go to that state. Sorry, we will go to that direction. So we will avoid to check or process this state compared to this one, since this one is led to the goal uh, more more faster compared to this one. Okay, uh, so in the, even though if we use the not the depth first but the UCS, the not this one, in the uniform course search, oh, there is no illustration in here. For the uniform course search, we have two situations, which is we have eh, sorry, not the uniform cost search. Yeah, the uniform cost search. In the uniform cost search, still we follow some path. It is resulting the lowest cost based on from our initial state going to the next state, and then we will sum or accumulate the cost from each node to another node. Meanwhile, still that algorithm didn't have any informations which in which direction the goal is. Okay, so for the next class of algorithm, we will use something called as a heuristic uh, formulation, or we will call it as the informate search. The heuristic is coming from the Greece, uh, namely Euryskene, which is berarti mencari, or I found it some story mentioned that Archimedes used the similar word, almost similar to the Euryscan, which is eureka, which is when he take a bath and then thinking about something, and then going naked from that bath, going to go outside without any clothes at all. I forgot what formula that he think about, but yeah, that's story that it's Archimedes said, Eureka, or there is something that I found, or there is some informations that we can use. Okay, in our programming world, the heuristic is a different thing compared to the algorithmic. When we say that the algorithmic, it means that we followed something exactly, which is what's the algorithm state in there. Meanwhile, for the heuristic, there is some kind like an intuition, okay, intuitions where we will follow our step. It's it's still algorithm, but it's something which is not very precise on a things. Okay, not something that's based on the, what is it, script, uh, the statement by statements, not something like that, but we have something which is kind of like a feeling for when we compare to human. Okay, so in our task, the heuristic is a function. Okay, so we need to define a function which is will provide an estimation. So the value of this function is actually estimation to a solutions. Okay, let's say that we have uh, a function like this. For example, like when we have a point a, b, c, and d. Okay, we can go to from A to B if we say that there is a heuristic which is 16. The function of our heuristic is 16, which is we will say that this function is not quite good enough. Okay, why? Because in the actual one, we will have the distance between point A going to the point B is not 16. Okay, and then the other thing is when we say that the values on the edge is 100. Meanwhile, for the B coordinate is 35 comma 10, and then the C coordinate is 55 comma 10, and we will say that this estimation, the cost estimation or the function estimation is not quite good enough as well. And we can compare which heuristic is the best one or not best one. For example, like from the C to D. Okay, we have three values in here, and we can say that from B to C, this one is not the best heuristic. The best heuristic is coming from the C going to the D one. Okay, why? Because that value demonstrate the what is it approximately similar to the original cost. Okay, so this is it's only an illustrations. I should explain why there is an idea about it. So if we have a heuristic function, if we have a heuristic functions, the heuristic is we can use that function as heuristic if the estimated values estimated values dihasilkan by those function is not overestimate to the actual cost. Okay, so there is a rule we can use a heuristic function if this statement is applicable. Okay, if the heuristic function is overestimate, then the process or the searching process will be not optimum. Okay, meanwhile for our algorithm using the heuristic, we will find something which is optimum. Okay, and then the next one is our heuristic function. We will say that the estimated is close to the uh, when it's close to the actual cost, we will say that those heuristic is quite good enough. Okay, so the more it's close to the actual cost, then the better the heuristic function that we propose. Okay, that's where this illustration came to our next slide. Okay, imagine that this one is a heuristic. Okay, in the next case study, we won't give the heuristic is a value on the edge, but the heuristic is the straight line distance, since the straight line distance is approximately close to the actual values. Okay, so for example, like we have from A to B, the heuristic is 16, the B to C, this one is 100, and from C to D, this one is 10. And we can see that the straight line distance is close to the actual cost. So yeah, it's the best heuristic. We can use this one as our heuristic. Okay. There's a formula, for example, like using the Euclidean distance when we have to coordinate x comma y coming from A point to B point, small a and small b. We can subtract those y coordinate and then make it to the power of 2 and then subtract for the x coordinate and then power with 2, sum of all those formula and then square root of this formula will obtain the distance, which is our straight line distance, or this one is normally we will call it as the Euclidean distance. For the 8 puzzle, there are information, or there are some proposal which is uh, demonstrate for the heuristic things. For example, like you know that this one is a state, this one is not our goal state. Okay, meanwhile for this one is our goal state. So coming from this state, we know that there are differences. For example, like the first block, since it's on its positions, so we don't have any differences in the first block, the second block as well as the third block. Okay, so we have differences in the next one, coming from the fourth until the eighth one. Okay, so there are some heuristic possibilities for the eighth puzzle. The first heuristic is the number of block which is wrongly positioned to the goal state. For example, like this one, we will calculate. We have one block which is not in its position, the second one, the third one, the fourth, and then the fifth one. So we have 5 blocks. Using the first heuristic, we will have that the first, second, and the third is on its correct position. Meanwhile, there are 5 others which is not in its position. So we will have our heuristic is approximately around 5. What does this 5 number means? We will say that it's just an estimation that to solve this puzzle, we will need approximately around 5 steps. Okay, I don't know which one is the step is, but probably we can go there, going there, 7 move left, and then 4 move left, 5 move up, and still it's not work. But yes, the heuristic is just an approximation. Sometimes our solutions are higher compared to our heuristic. Okay, we have demonstrate with this one. Okay, with the first heuristic. The other heuristic for the 8 puzzle is we can calculate how many steps that we need to obtain from each box to its correct positions. Okay, for example, like when we have this initial state, we will go to that state. We will sum that since the first block is already in its position, so we don't need any step at all for the first block. So we will have a 0. 0 plus the second one also 0. The third one also 0. Meanwhile, for the fourth, since the correct position is over there, then it will need 1 step and then 2 steps, or we will have 2 in here, so 0 plus 0 plus 0 plus 2. And then the fifth one, we can position it to the correct one by going up and then going left, or going left and then going up, and both of them needs around 2 steps. Okay, so we will have 0 plus 0 plus 0 plus 2 plus 2, and then for the other one we will calculate using the same ideas, and then we'll have this kind of things. So for both for 1, 2, and 3, we need no step, and then for 4, 5, 7, and 8, we need around 2 steps, and then for the sixth one, we need around 3 steps. That's why using this kind of formulations, we will have around approximately around 11 11 values, which is representing our estimation to solve our problem. And if we solve our problem, what is it, correctly, perhaps we need one, and then two, and then three, and then four, and then five, and then six, and then seven, and then seven going down, fourth, seven, eight, nine, 10, 11, and 12, approximately around 12. Okay, so using those heuristic function, we know that both heuristic function have differences. The first one is when we calculate using the original step uh, needed to solve the problem, we will have a gap around 6 coming from 6 or 7 coming from 12 minus by 5 from the previous one, 7 minus by 5. Meanwhile, for the second one, it's close to the original one, which is for example like 12. I'm not quite sure whether 12 or 11, but let's say it's 12. So our differences between our heuristic and the actual solution is around one. Okay, only one step differences. So we can say that this, since there is not we don't have a lot of differences in the second heuristic, we will say that the second heuristic is better compared to the first heuristic. And when we deals with the eight puzzle, and we calculate for the depth solutions is approximately around 2. Probably the first heuristics need around 6 node, and then the second heuristic, it's also uh, need around 6 node. Meanwhile, for the more complex problems. For example, like when the solution is on the 10th depth, the second heuristic only generate a smaller number of nodes, which is require smaller memory as well as uh, faster computational cost compared to the first heuristics. So that's why when we deals with the heuristics, make sure that our heuristic is as close as our actual cost. Okay, this is the illustrations coming from the Russells, which is the artificial intelligence, a modern approach book. You can read for later on. And then for our next problem, how about the water jug problem? We know that in the beginning we start our thing with the heuristic. Well, for this one, to be honest, there is no heuristic function for it. Okay, so why there is no heuristic function for it? We say that for example like we have a 5 gallon and then fourth gallon, we don't quite understand which one is leads to the 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 three going to for the formulation of how many steps we need to solve the problem coming from the water level in there. For example, like we might have this one is a 0, but however that one already have the solutions. We just need one step, another step to solve the problem. Okay, so doing that sorry, I'm not quite good in explaining this one, but I will try. Um, Having that situations, we will say that since there is no heuristic function for these solutions, we won't be able to apply the informative search algorithm into the water jug problem. Okay, so that's the point among this slide. And then when we deals with the heuristic search, we have a couple of algorithm, which is namely BFS. It's different coming from the previous one. We will call it as best first. We can also use the second one, which is greedy best first search, and then the A star, and then the other is the pengembangan of A star, uh, the development of the A star or the variations of A star, namely iterative deepening A star, simplified memory bonded A star, bidirectional A star, as well as PIM A star. Okay, I will explain the first sorry, the second algorithm, and then the third the third algorithm more detail in the next slide. However, in this slide, I will explain that the iterative deepening A star is almost similar to the iterative depth first search. The idea is coming from that things, except that in the iterative deepening search, we maintain the depth level to be explored in our iterative deepening search. In here, in the iterative deepening A star, we will use values, namely the heuristic values. Okay, I forgot whether it is heuristic values or the composition of the heuristic and as well as the cost values. Some values, let's say that we have a values which is incrementally uh, added into our A star. Therefore, our A star will act as similarly to the iterative depth first search. Okay, that's for depth iterative deepening star. I can explain using pseudocode in here. For example, like there is a limit. Um this one is the sorry, uh, iterative deepening A star or IDA star is more like this. We will have our limit, which is we will set to 0, and then we will start while we haven't find the goal to run a run a star with a limit. Okay, and then if we can change using the repeat mode. Certain limit, and then if until we find goal. If we haven't find the goal, then limit is lowest function of lowest function of our leaves. Okay, lowest values of a function in our lips. Yeah, this is the pseudocode for the iterative depending star. So the remaining things for this one is how to run the A stars. That's we will discuss for the later on. And then the next one is for the simplified memory bonded A star. This one is deals with the A stars in limitless memory. For example, like in the previous years, for example, like in 2002 or 2003, the handphone or the cell phone, we have no we don't have any, we don't have a lot of memory for that era. So some researchers what is it propose this algorithm to to handle the limit, the number of memory which is required in our searching mechanisms. Yeah, they are quite difficult to understand the simplified memory bonded star, since there is a pruning mechanism as well as the adding mechanism, which is there are certain rules which is to be honest I forgot now how to explain that one. So I will say that this one is proposed to handle the low memory in a certain conditions. And then the second one is the bidirectional A star, which is mostly almost similar to the previous one, bidirectional search, using the A star as the base. And then the second one is the modified bidirectional A star, and then the other one is yeah, that's the what is it? The pengembangan or pengembangan from the A star algorithm. Okay, I never learned about the modified bidirectional ASTAR, dynamic weighting ASTAR, and then beam ASTAR. So if you would like to know more about it, then you can search for it in the internet. Okay, this is the algorithm for the best first search. For the best first search, the algorithm is we can say that it's almost similar to the uniform cost search, except that we use different values. Okay, the different values, the differences between uniform cost search with best first search is in the uniform cost search, we use the actual values. Meanwhile, for the best first search, we use the estimated values. Okay, so we have to function in there. The first one is the actual values, and then the second one is the estimated values. I will explain about it, so you will be able to use it in the R-star and know better in the uniform courses. Let's say I need paint. So what's the difference between the actual values and the heuristic one? Okay, let's say we have uh, a position in there. Okay, we can call it as A, and then from A, we want to go to B. Okay, we want to go to B, and coming from A, there is no road that there is no direct operation, or there is no direct route from A to B. From A, we need to go to the C first in here, like this. And then from C, there is also route uh, coming from C to B. Let's say if we have the distance from A to C is approximately around 400 meters. Okay. Meanwhile, for from C to B, we have the the distance is around 300 meters. Okay. So uh, when we go from A to B, well, since we need to go to from A going to C and then going to B, okay, we will have around 400. This one is around 300, and then going there will need approximately around 700 distance. Okay, imagine that the actual cost is the actual values that we have in our real world case. Okay. Uh, Meanwhile, when we ask from A positions, what is the estimated values from A to B? We can say that the estimated values is the straight line distance from A to B, which is approximately the equidistant distance value, which is 500. Okay, so sorry, I need to uh, use the different color so you will understand this one. So in the red one, we will say that this one is the heuristic. Meanwhile, for this one is the for the black one is the actual cost. Okay, what's the difference among them? Okay, let's say we want to go from A, our home, to our friend's home, which is in B positions. Uh, we want to go there, and then we travel from A to C. Okay, the question is how many costs that we already spent in our searching things. We know that we already step around 400, right? So our actual values we already walk approximately around 400. Okay, and then if our case is in C, we remember that we forgot we need to bring something for our friends in B positions. And then since we forgot something, we go to A again. Okay. Imagine that since we go that direction, A to C, and then C to A, remember that when we walk, we are tired. When we walk, our time consumed. When we walk, perhaps the motorcycles, the gas in there is decrease in there. Okay, so we can say that the actual cost is not zero again. So when we have the three search is like this, from A to C, and then from C going to A. This one is we need around 400. Okay, from C to A we need around 400 plus 400, sorry, plus 400. Why? Because we go from A to C, we spend 400, and then we spend another thing, another effort, which is also 400 again. If we want to go back to C again, continue since we still have a mission which is haven't finished yet. We will say that we will spend another 400. Okay, so this one is 3 times 400. That's the characteristic of the actual cost. Okay, when you go from one line to another line, going to the similar line again, we will accumulate our costs. uh, we will increase and accumulate our costs. Meanwhile, for the estimated cost, we can we can uh, we can ask how many meters, how many need from A point to the B point. Since we use the straight line distance, we can say that the estimated cost is around 500. Okay, so in this one, the estimated cost is around 500. Meanwhile, when we go to C, okay, how many meters again? How many distance? How is the estimated cost from C to B? Okay, we can say that since it's also the straight line distance in there, we can say that the estimated cost from C to B is around 300. Okay, when we go back to A, we will ask the similar question: how many distance is the approximation from A to B? Since the approximation is never changed, the approximation we never accumulate that one, we will answer that to go to our goal, which is B, approximately we will need around 500 meters again. And then going to that C, we will have around 300 as our estimated cost. Okay, I will stop my explanation to these positions, so you can understand that there are two differences between the actual cost as well as the heuristic or the estimated cost. The UCS, sorry, the UCS, it used the actual cost, actual. For the next one, we will use some informative things, which is the heuristic. For example, like the greedy BFS, we don't use the actual cost, but we use estimated one. Okay, explanation to this point. If you have some difficulties to understand this my explanations, please go forward for some questions. Sorry, I think it will be better if I write using this one. Halo, apakah ada pertanyaan mungkin, Mas, Mbak? Halo, Mas?
Halo,
Ya, Mas Sulhanur. Mas Han. Bisa dipahami, Mas Han?
sejauh ini bisa
Bisa ya. Terima kasih. Ya, jadi ada perbedaan antara actual cost dengan estimated cost ya. Perbedaannya ada di kalau actual cost, kalau kita pergi ke tempat yang berbeda, namun dia bolak-balik seperti itu, maka harus kita akumulatifkan. Tapi kalau estimated cost hanya di posisi itu hingga ke cool state, dia estimasinya berapa, seperti itu. Nah, ini yang akan menjadi dasar bagi algoritma-algoritma berikutnya, yakni best first search. Best first search ini we will start our algorithm, which is from the initial state as the open state, and then we will maintain the close as the empty one. Okay, so we will have this one. Open is initial state, and then close is equal to empty empty list, and then we will repeat our goal until we will find no node in the open. Okay, what we will do something like this. Pick up the best nodes in the open. Okay, and then if those nodes is equal to goals, then succeed. We will exit from our loop, and then if it is not our goal, then put this initial state into the closed state. Okay, and then what is it, bangkitkan all, generate all the successor of the state. For example, like we have state A, and then we will generate the child of state A, all the successor, and then for each successor we will do the next one is if we never generate those successor, then evaluate the successor, and then add to the open, and then if it is not, then we can go to the we can what is it, we change the values of the 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 estimated cost, but I don't think the estimated cost is changed in there, but yeah. Okay, uh okay, so the greedy BFS use only the heuristic values. In here we use the heuristic values, and doing so we will have the complete but not optimum. Why? Since there is a problem in here. For example, like when we iterate this map using the greedy BFS, then coming from the S, we will have approximately around this one. We use only this heuristic. Okay, the heuristic is coming from S, approximately going to the goal is around 80 values. From A, it's also need around 80 values. From B, approximately around 60 values, and so on. Okay, if we want to go from S to G, okay, then we have the initial state is equal to S. Then we will have our open is S, and then our close is empty there, and then we will look for the first one. Since S state is S, we will take out values from the open node, and then we check whether S is goal or not. Since it is not a goal, then we will generate the child of S. For example, like we have the A, B, C, D, and E. and we use the values of hn in there. So we have the open is the a of 18, and then the b of 60, and then c of 70. We use these values, and then d of 85, and then e of 74. And then we need to sort this one from the smallest to the largest. So we will have this one. Okay. So we already sort this one, and then okay, this is coming from the S. Sorry, I need to maintain the solution. Okay. Okay, so the next one, we need to going to the loop again. Sorry, and put this one as the close state, as this one is as 80. Okay, the next one, we go to our next loop, the second loop, which is we need to delete a point in there, which is this one, and then we have our open. Sorry, state is equal to s. The open state, we delete a state in there. We have the closed state is this one. Okay, so coming from b, we have b. We can travel to going to A, going to F, and then going to S, as well as going to K. Okay, so we check this one is not our goal state, so we need to generate the child of it. Child is equal to SPA, comma SPS, comma SPF, comma SPK. Okay, and we need also maintain the estimated values. For A is 80, for S is 80 as well. For F, this one is 70, and for K is 30. Okay, and then we put it to the open state, and then sort it. This is the smaller one. We put it in the front of our open state. Uh, this one is not small enough, so we will put in there. And we already sort our our state, so our state in the open list. So we put that one into into the closed one, and then we go to the third loop. uh, the third loop is like this. uh, Let me finish this one first, Mas, so I will give you an opportunity to ask something. Okay, so we have this one as our state, and then we will delete this one, evaluate whether the k is our goal or not. Since this is not our goal, then we will generate our child. We can travel to F, travel to B, as well as travel to G. Okay, so the child is equal to going to F, going to B, going to the G. This has zero estimation, and going to F is 70, going to B is around 60. F is 70, B is around 60, around 60. So we will add this one to the open list and then sort this one. Okay, it's already sorted from 0, 60, 70, and so on. So in the next loop 4, when we delete this one, okay, as our state from our open state, okay, like this, we'll evaluate whether G is our goal state or not. And since it's our goal state, then we will say that we will stop from our algorithm and return that the solution is from S going to B, going to K, and then going to G. This one, from S going to B, going to K, and then going to G. That's the how the greedy BFS work. Okay, I see some chat in there, Mas Andi. Do you have any question, Mas Andi?
Yes, I do not understand what is your reasoning because I don't know which one is the heuristic value
Mhm.
you mentioned is at the picture or at the table. So,
Yeah. Uh, our heuristic value usually denote with the HN. Okay, the HN. Meanwhile, in this slide, we have the HN. This one is the N. With this one, we have the HN, the heuristic values for N, which is this one. These values in the table. That is the heuristic values, Mas Andi. What about these values? Okay, the question is, what about these values? These values is the actual values in this in the story. We have two values in here, the actual values, and then the estimated values, the actual cost and the heuristic one. Is it answer your question, Mas Andi?
oh, okay, so we find the maximum, uh, we find the uh, final state using heuristic.
Yeah, we
And
we find the we search the path how to operate coming from the initial state going to the goal state using the heuristic. Jadi dari initial state, pertanyaannya adalah pada saat dari initial state S, ini kan kita bisa pergi ke ada 5 kota ya, 5 junction mungkin ya. Titik A, titik B, titik C, D dan E. Oke. Maka karena dari satu state bisa pergi ke sana, kita harus generate tree-nya. Jadi kalau kalau yang sebelumnya kan ada ini ya. Sorry. Um, uh, kita cek S. Oke, kita cek S. S ini cool atau bukan? If S is not cool, then we will generate all the child of S. We have A, B, C, D, and D and E, and we will have this one is A, this one is B, this one is C, this one is E. Oh, sorry, this one is D, and this one is E. Okay, and for the illustrations, we will have something like this. Okay, different to the breadth force and the depth force on the greedy BFS, we use values in there. For example, like we use the heuristic one. Okay, so we will draw the heuristic values for A, which is the heuristic values for A is a T in there. Heuristic values for B is 60. Sorry, 60. For C is 70. Meanwhile, for D is 85, and for E is 74. Okay, using the almost similar to the uniform cost search. Okay, we will evaluate the lowest one, the lowest estimated, the lowest heuristic, which is this one. Okay, so we check B. We check whether B is our goal or not. Since our goal is going to G, so we don't say that B is our goal, right? Coming from B, we have four options. We can operate going to A, we can go back going to S, we can go to F, and then go to K. Okay, so we will have something like this. We can go to S, we can go to A, we can go to F, and go to K. Okay, all of these are the child of B. Okay, and we need to maintain as well for the heuristic values. We have 80 for S. If you see this one, 80 for S, and then 80 for A. This one also 80, and then for F is 70, and then for K is 30. Okay. Using this tree, we know that K in here is the lowest values of heuristic, having the lowest heuristic values in there, compared to the other leaves. A is 80, C is 70, D is 85, E is 70, 74, and so on. We will have that this node is the lowest one. Okay, so we will travel to that one, check whether this one is goal or not goal. Okay, if it is goal, then we stop. However, in our case, this is not the goal. Okay, this is not the goal. Therefore, we need to expand the K node. Okay, the K node. From K, we can travel back to F, we can travel back to B, or we continue to G. Okay, can go to B, we can go to F, or we go to G. Am I correct? Okay, F, B, F, and G. Okay, the heuristic values for B is approximately around 60. The F is 70. I know it from here. And then the G1 is 0. If yeah, the G1 is 0. This is the child of K, right? Like this. Okay. So using this tree, okay, we need to expand the tree. We already expanded, and then we need to check the lowest one, which is in here, G having 0 as the heuristic values, like this. And then since this one, that one is the goal state, then our searching process will stop and return the solution is from S. We need to travel to B. Okay, and then from B we need to travel to K. Okay, and from K we need to travel to G. So the result of our searching algorithm always a path in there, from S to B, B to K, K to G. Okay, and if we ask how many calls uh, are needed when we travel from S to B, continue to K, and then continue to G, then we need to see the actual cost. The actual cost from S to B is equal to 25, and then going to K is around 50, and then from K to G is around 30. So we will need around 105 values in there. Okay. The question is whether that cost is the lowest cost or not the lowest cost. Can you find something lower than 105 in there? The solution from S going to G. Is there any other solution which is lowest to compare to 105?
By using actual cost or heuristic
Actual
search.
cost. Actual
Uh,
cost.
I think from S we can direct to A first.
Mhm,
After that, from A to B.
mhm,
After B, we go to the F.
mhm,
From F, we direct to K.
mhm.
Until that, we finish at the G.
Okay. So it needs 70, 70 plus 25. It's around 95, right, Asandi? It's lower
Yeah.
than the other solution, which is A, and then directly to G, which is 100. Yes, that's correct. That's, I think that's the lowest one. Okay. So using the greedy BFS, we find that our solution is not the best one. Okay, the best or not best, the best or not best are determined with the actual cost, which is we have 25 in here, we have 50 in there, and we have 30 in there, which is when we add those values approximately around 105, which is this is not the best, not the best solution. Okay, the best solutions you can achieve by running the uniform cost search. For example, we already discussed that uniform cost search is the guaranteed if there is a solution. The solution always find the best solutions. So we will find the from S to A to B, and then going to F, going to K, and then going to G. Is there any other lowest solution? I don't think so, right? It's 40, it's 50, it's 80 longer solution, 100 longer than 100, 65 more than 100, 65 plus 60 longer than uh, 100. So yeah, that's the lowest solutions. Okay, so as you can see that using the greedy BFS, we won't be able to find the best solutions. Our solutions not always the best solutions. So that's the property of the greedy BFS. This is the illustration. Okay. Okay. The actual cost is approximately around 100. It's not optimum. Okay, the optimum one, which is Mas Andy already found, we can find around approximately around 95. Okay, I think I will stop my explanations. I have a running nose in here, so I need around 10 minutes approximately. Can we have a break around 10 minutes? Is it okay, Mas? But
Okay, so no problem.
nggak apa-apa ya, Mas Hans. Kita break 10 menit. Kita ketemu di 16:52. Oke.
Baik, Mas.